Today we are going to consider exponential decay functions. Decay is what happens to the knowledge in your head when you don't use it. So use it, and it will grow. So, remember with the exponential growth, we had equation of the form y is equal to a times b to the x. A was the initial amount, b was the growth factor. Something special about that b was that b was greater than 1. It represented growth. So we thought of that as 1 plus our rate. We would add our rate to 1. With exponential decay, we are still in the form y equals a times b to the x, where a is still the initial amount, and b is not the growth factor so much, but the decay factor. Now, something about that number is that number has to be greater than 0, but it has to be less than 1. So b is going to be between 0 and 1, and we're going to think of that as 1 minus our rate today. Instead of adding it to 1, we're going to take it away from 1. So, if you bought a computer for $800, that's your initial amount, and you expect that the computer will lose value of 29%. So we're going to do 1 minus 0.29. So we do really what it keeps. It keeps 71 or 0.71% of its value. And we want to see what it's worth after 4 years, so we put it to the 4th power. So 0.71 raised to the 4th power is 0.254 times 800 is $203.29. That is the value of the computer after 4 years, decrease in value 29% per year. So now, looking at functions, are they growth or decay? The initial amount is 40 in each of these. That doesn't determine growth or decay. This number right here does. That number is between 0 and 1. So this example here is going to be decay. Whereas here the b value is greater than 1. 6 divided by 5 as a decimal is 1.2. Notice the numerator is bigger than the denominator. So this one is going to be growth. So if we are given the equation y equals 80b to the x, or 80b to the t, what values of b make this model exponential decay? Well, it's got to go down, so it's got to be between 0 and 1. 0 is less than b, which is less than 1. So between 0 and 1 are exponential decay, and then growth, b is going to be greater than 1. So let's set this one up. We have a $500 investment, and it decreases in value by 2% per year. So the initial amount is $500, and again, we're keeping 98%. How much will be worth after 30 years? So 0.98 to the 30th power. It's 0.5454. And then we want to multiply that by 500. $272.74. And finally, example 4, we have a $45,000 piece of machinery. That's our initial amount, and it depreciates. Depreciates another word for exponential decay, 16%. So that means it's going to keep 84% of its value, so 0.84. And we want to know after 5 years how much it's worth. So 0.84 raised to the 5th power times 45,000. That's $18,819.54.